Hi everyone, my name is Emily and today I'm going to talk about two projects we completed last year at the Ontario Beef Research Centre. And both projects were looking at the performance and environmental benefits from biochar supplementation in beef cattle grazing systems. So as we know, there is increased pressure to reduce agricultural-based greenhouse gas emissions, and primarily enteric methane emissions are the main concern. So as such, methane mitigation strategies that reduce methane emissions without compromising any production efficiencies are required. So biochar could be a potential methane mitigation strategy. And essentially, biochar is a carbon-rich product that is produced from burning organic matter under low oxygen conditions. So biochar has been shown to reduce methane emissions in vitro through some lab work, but has not been extensively studied in cattle, and the mode of action is still not fully understood. However, there are a few hypothesized modes of action. The first hypothesis is that biochar may absorb gas in the rumen, resulting in less methane release. The second is that biochar may increase the inert surface area in the rumen, resulting in improved microbial habitat. And the third is that biochar may alter the microbial community in the rumen. So we had two primary objectives for our two experiments. The first objective, was to determine the optimum dose of biochar to reduce methane emissions from beef cows. So this was done through our first experiment in the barn. And then our second objective was to determine whether biochar supplementation can reduce methane emissions from grazing beef cows. And this was our second experiment conducted on pasture. So as I was saying, our first experiment was conducted from January to April of 2020. And it was conducted as a replicated 4x4 Latin square using 8 late gestation beef cows with biochar supplemented daily at 0, 1, 2, and 3% of dry matter intake. The experiment consisted of 4 21-day periods, and each period consisted of 14 days for treatment adaptation and then 7 days for data collection, including things like dry matter intake and methane emissions. So for this experiment, we had a biochar pellet and a control pellet. So the biochar pellet consisted of 45% biochar, and then the remaining ingredients were wheat midds, canola oil, and dry molasses. And then our control pellet consisted of everything in the biochar pellet minus the biochar. So this table kind of breaks it down. So you can see that at the highest inclusion rate of 3%, each cow on that treatment was getting roughly 980 grams of biochar pellet per day. And then if they were on the other end, the control treatment, this 0%, they were getting roughly 539 grams of control pellet per day. So again, we would make up these, I guess you could call them cocktails of that specific combination of control and biochar pellet for each cow per day. And then we would top dress it onto the base diet. So you can see here that this is a combination of the biochar and the control pellet. So likely the cow on this treatment was either in the 1 or 2% treatment. And again, at the Ontario Beef Research Centre, they have the Incentec feeding bins, which we definitely made use of because with that system, you can assign individual cows to their own feeding bin, such that for experiments like ours, we can individually feed each cow their specific treatment. So moving into some results for this first experiment, the main goal was essentially to determine what dose of biochar we wanted to use in our second experiment on pasture. And if you look at methane emissions up top and then carbon dioxide emissions on the bottom, there were no real differences in methane emissions or carbon dioxide emissions between any of the 4 treatments. However, we did have to choose one dose to use for the second experiment. And so when you look at the 1, 2, and 3% doses up here outlined in blue, we ended up going with the 3% dose just because numerically it was lower compared to the other 2 doses here. And essentially what is shown in this blue or rectangle here is grams of methane released per day on each treatment. So again, between the 1, 2, and 3%, we ended up going with the 3%. So that takes us into our second experiment, which was conducted on pasture from June to November of 2020. And this experiment consisted of 64 cows and calves divided into 8 groups of 8 cow-calf pairs. And we used a rotational grazing system. And biochar was supplemented at 0 and 3% of estimated dry matter intake using portable troughs. And this experiment was conducted as a crossover design, essentially meaning that each cow was on each treatment twice. So 2 times on the control and then 2 times on the biochar. And each period consisted of 28 days, 21 days for treatment adaptation, and then 7 days for data collection. And you can see here, we collected our methane emissions using C-lock green feed trailers, which is shown in the photo here. So essentially, the cows are enticed to come to the unit because it drops pelleted feed. So when it approaches the unit, it scans its RFID tag, then drops pelleted feed. And then while the cows are consuming those pellets, it draws in air past the animal's muzzle. And then using infrared sensors, it measures the concentration of things like methane and carbon dioxide emissions. So again, in this experiment, we had the biochar pellet and the control pellet, similar to experiment 1. And this time, if the cow was on the control treatment, they were getting, roughly 590 grams of control per day. And then if they were on the 3% treatment, they were getting just over a kilogram of biochar pellet per day. So for some results for our second experiment, similar to our first experiment, there were no differences in methane emissions or carbon dioxide emissions between the control and biochar treatments. So up top here, again, the first row is showing grams of methane released per day. So on average, the cows on the control treatment were releasing 252 grams per day. And then on the biochar treatment, they were releasing 262 grams of methane per day. So these differences were deemed not statistically significantly different. And therefore, it was deemed that biochar was ineffective for reducing methane or carbon dioxide emissions. And again, we wanted to make sure that biochar supplementation wasn't negatively affecting animal performance in any way. So in our second experiment, we also looked at things like dry matter intake, average cow body weight, calf body weight, and cow body condition score. And none of these parameters were different between the 2 treatments, essentially indicating that biochar supplementation did not negatively affect animal performance in any way. We also took lots of fecal samples throughout this experiment on pasture, and not surprisingly, total carbon was higher in the biochar supplemented cows compared to the control cows. And this wasn't, overly surprising since it is a carbon-rich product. But other than, total carbon, none of the other parameters in the manure nutrient profile were different between the 2 treatments. So overall, our basic conclusions were that biochar was ineffective for reducing methane emissions from beef cows, but we did find that animal performance was not negatively affected by biochar supplementation. So lastly, I'd just like to give a big thank you to all the staff at the Ontario Beef Research Centre, and then also all of the members and volunteers of the Wood Lab for all the help in making these 2 projects a success. Thank you.